Okay, how did I get into engineering? Well, it was an alternative to what I really wanted to do, and that was become a pilot, commercial pilot. And when I was young, I'd look up in the sky, and it was World War II, and I'd see all these beautiful airplanes flying at high speeds over my house, going from one airport to another. And I just wondered why I couldn't do that too. So I ended up joining the Civil Air Patrol in New York. And I was a cadet. I was 14 years old. I think that was the minimum age. And got involved in airplanes and what have you. And one of the things that the Civil Air Patrol did at those days, they were still patrolling the coastal waters for submarines, and they would be the first ones to radio back that they saw something suspicious in the waters. Well, I figured that might be a good way to get a ride or something. And sure enough, they had a program for the cadets, if they wanted to do it, that they would give us a ride every once in a while in a light aircraft. And I showed up at the airport at Mitchell Field on Long Island one day for my ride. And you'll enjoy this. And they told me to go out to that airplane over there and wait for the pilot, which I did. And I was walking around the airplane and no one was coming. And finally this young woman was approaching the airplane, and I was wondering whether she was going for a ride too. Well, she was. She was the pilot. Turned out that she was 19 years old, and her name was Lieutenant Ann Bang. I will never forget her. Okay, she gave me my first ride. And I'm sitting in the back seat. It was tandem, you know. I'm sitting in the back seat, and I'm saying to myself, mind you, this is 1945. There were very few women that were flying airplanes. That's changed today, fortunately. But I'm saying to myself, how come this young girl is flying an airplane and I don't know how to fly one yet? You know. So talk about, yes, talk about being chauvinistic. Okay, if she could do it, I could do it. And so I went home to talk to my father about it, and I said, you know, Dad, I really would like to take flying lessons because I really think I would enjoy it. I flew with this one woman, you know, over the weekend, and it was great. And he looked at me. He was an immigrant from Italy, and he said, son, he says, I work 7-8 days a week. This is what I do. I don't have spare money to have you spend it on learning how to fly. And he wasn't too enthusiastic about it. And so I kind of turned that off. Well, my older sister, 4 years older than me, she was 19 at that point. She overheard that, and she was she was a young woman of the coming age, okay? And she looked at me and she looked at him, and she says, Dad, this young guy is 14 years old now, but in 4 years he's likely to be 18, and he's liable to have a family already with kids. Are you going to tell him then he can't fly? Okay? So Dad thought about it a while, and he says, I don't have any extra money. He says, but I run a construction gang in New York, and if you want to push a wheelbarrow like some of the laborers can't do, he says, I'll pay you what I pay them, $13.95 a day for pushing a wheelbarrow. He says, but you got to be strong because you got to go, that barrel's got to come up a ramp from story to story. And the building, I guess, was like 15 stories high. So it was a lot of work to push that wheelbarrow up these ramps inside the building. But I did it, and he'd give me my $13.95. Well, I do that on one of the Saturdays when there weren't too many inspectors around, realizing that I was a young 14-year-old kid pushing a wheelbarrow on a big construction gang, okay? And he gave me my $13.95. And the second Saturday then of the month, I would get out on the highways in New York, use my thumb because I wasn't allowed to drive. You don't drive in New York until you're 18 years old. Okay. Yeah. So I was able to hitch a ride each time to the airport, and I'd take a flying lesson. It cost just about $13, so I had about 95 cents left over. Okay. And I'd have to hitch my ride home again. So it was kind of threatening to a certain degree. I was only 14, 15 years old. And but in those days, it was relatively safe to do things like that. I say relatively in comparison to today. You'd never do that today.
Right.
So
but you had such drive to do that.
I had such motivation that I wanted to do that. And I sold when I was 16, and by 17 I got my license, which was the minimum age for the FAA. And I was just so happy and thrilled about that I cornered my sister, who could drive at that time, and I said, Gloria, how about driving me out to the airport and I'll take you up for your first airplane ride? Well, she was gutsy and everything else. Sure. So she'd drive me to the airport, and I took her up for her first ride. And I flew from the center of Long Island into New York City. I flew around the Empire State Building and then circled the Statue of Liberty, and then I took her back to the airport. And that was my thank you for having broken the ice with my father. So that's how I got into aviation. Okay. And that's where my real interest was. And I went to a school in Brooklyn, which was a unique school called Brooklyn Technical High School. And they had a number of courses there. One was aeronautical engineering, which is the one I took and graduated in. There was another one called mechanical engineering and electrical engineering and architectural engineering. So it was all engineering-oriented school. You had to take a test. There were 5,000 of us who took the test to get in when you became a ninth grader. And they selected the top 500, basically, of the 5,000. No women, by the way. Okay? That's also changed. Okay. So anyhow, make a long story short, I got my degree in aeronautical engineering. It was a degree from a high school level, not college. Well, we didn't have money to send me to an aeronautical engineering college, and so I went to the nearest free college in New York called CCNY. That stood for City College of New York. And there were some pretty famous people that went through that school. It was an outstanding school, but they didn't have aeronautical engineering. To get that, I would have had to go to NYU, New York University. So I had to settle on something else. So I settled on mechanical engineering to get my degree, thinking all the time that someday, after I got my degree, I'd get into aviation seriously. Well, got my degree in mechanical engineering, and I had met my wife-to-be, and things worked out that I got my degree in February of that year, got married the same week to my girlfriend, and I'm still married to her, by the way, over 65 years. We're a dying breed in more ways than one.
Congratulations. Okay. That's an amazing accomplishment.
Yeah, that's right. That's more than anything else I've done. But anyhow, got married, got my degree, and I got my second lieutenant's ROTC commission. And that meant that in about a year I had to serve at least 2 years in the military. So the first year I didn't have to go in service right away. I took a job in California, and my father gave me his car, and I had a car to drive all the way to California. Got out there and I worked for a company called American Aviation, and they were working on a program called the Navajo, which was an intercontinental, not ballistic missile, but cruise missile. Did not have a pilot. It was totally automatic, and would have had the capability to drop a hydrogen bomb within 300 yards of the center of the Kremlin. Completely automatic. Okay. Well, I got to work on the wind tunnel model of that for about my first year. Then I got my orders to go into service. Well, I had notified the Army of my work that I had done, and if there was anything that the Army found that was close to that kind of experience, I would appreciate an assignment in that area. Well, the Army did something good. They realized that there was something happening down here in Huntsville, Alabama, that involved rocketry, and they figured they'd go ahead and assign me down here. So that's how I got my assignment to come here. All my buddies went to Korea, I believe, at that time. And that was funny because when they were giving out the orders, the major was up on the stage at the school, and he'd say, Wilson, to Korea. You get up on the stage, you shake your hand, you got your orders, and you were on your way. And he went through about 15 names that way. Lambert, Korea. Well, it gets to my name, which is spelled M-O-R-E-A, pronounced Morea, But he looked at it and he said, Morea to Korea. And then he looks at the orders and says, well, no, wait a minute. No, wait. You're going to Huntsville, Alabama. He didn't know where it was, and neither did I. Okay.
And he's confused. How did that get on there?
That's right. So that's how I arrived down here. And I reported into General Toftoy, who was the commander of the post here. And he says, oh, I see you're a mechanical engineer. I said, yes, sir. He says, there's a German group down here. He says, they really need engineers. And why don't you go over and talk to Dr. Werner von Braun? He says, and see if he can find a place for you. He says, and I'll assign you to him. It's okay. That sounded like a plan. Well, I walk into von Braun's office on the next Monday morning. He already has my file. He's looked it over. And he said, I see you're a mechanical engineer. I said, yes, sir. He says, good. He says, I've got 9 laboratories. I'd like you to take the next 5 weeks off and go visit each of my laboratory directors and find out whether there's anything for you as a mechanical engineer that you might be interested in doing and they might be interested in having you do. So that's kind of how I got my first assignment. Mind you, I could take up to 5 weeks off finding my own job out here.
That's amazing.
That's right. So von Braun to me said, take the next 5 weeks off, go see my laboratory directors, I have 9 of them, find out what they do in mechanical engineering and whether you would be interested and whether they have something for you. Come back and tell me, and that'll be your military assignment. And that's what it was. Strangely enough, an area called heat transfer, which my background in college, I did worse in thermodynamics than any of my courses, except I took a course in Italian that was necessary. And I got a D in that one as well. So I got 2 Ds, one in Italian and one in the mathematics, the heat transfer. But anyhow, for some reason or other, I felt like that was an interesting part to understand the air ballistics and the aerodynamic heating and all of that. And so I went to work for one of the Germans in that field. When President Kennedy suddenly made the announcement that we were going to go to the moon, well, unbeknownst to me, von Braun was already assessing if that kind of a job came in this area, he needed some help. He needed some young Americans because all the Germans were getting very old, and he realized they were going to be dying on the job soon, So he needed to build the American capability of his organization. I didn't know that was the story at that time. Found out later, why I happened to be picked. But he picked me and for this new job that was coming along called the F1 engine development.
Okay.
And it was a biggie. And it was the thing that would power this Apollo into space that we eventually would go to the moon with. Well, I didn't have any qualms about it. I thought about, what do I know about rocket engines? Only what I could pick up in that first year here and there. So I didn't know very much about it, but I was learning a little bit about management, and I was watching von Braun, how he managed people, and he was a people manager all the way. He had the desire and the willingness to trust a program like the F1 engine development to this young guy that had very little experience, but he knew me because of a couple of things I had done where I interacted with him, so he knew a little bit of my background. One of which was he sent me to New York on a liaison assignment, and I was thrilled to go. Okay, but it was a company that was having trouble on the servo mechanisms in the Redstone missile, which was the Army missile at that time. And so I was pleased to go, although it was hard leaving the family. But I'd go up there for a week and come back home.
How long did that go on?
It went on for about 6 months.
Okay.
Yeah. But it didn't last very long. And pretty soon the opportunity came along to get into something like propulsion. And that was managerial experience that I got involved in at that time. It was technical liaison work, but you also got involved in running assignments to the laboratories here at the center and interacting with the chief engineers at the center. But along comes the go-ahead, as I say, by the president to go to the moon. And von Braun looked around, and he had 4 or 5 lieutenants that he had done the same thing to that he did to me. Pick your own place and see if you can make a contribution. And so each of us kind of got some key slots. He picked me for the F1 engine development, which at that time ended up, when we were going full steam, the budget at that time was $1 billion. $1960, $1 billion. That's like $7 billion today.
Right.
I'm 28 years old, and I suddenly have this awesome responsibility. Well, again, von Braun just felt it was necessary to train the new young Americans, because the Germans were a dying breed.
Right.
And he wanted to go to Mars and Venus and places like that. He wanted to explore the universe, and he wasn't going to do it with a bunch of old Germans that were falling apart. So he trusted me in handling this huge program.
What was it like for you to take on that responsibility?
Well, initially it was very intimidating, but I got to select some people to work the project with me, and that was good to do. And I've kind of followed a lot of what I detected with von Braun. That is, you have to not just keep people and just forget about them. You have to work with them. You have to deal with them, and you have to help them with their problems. And if they have a personal problem, help them out. In fact, I miss one little story I tell about von Braun all the time. I had spent some time in this liaison office with a fellow by the name of Kurt Lindner, who was one of the Germans. And Kurt had a heart attack, almost died, but he came back to work right away. He survived it. And the day he comes back to work, von Braun walks into his office, and I was there in the corner with my desk. And they didn't ask me to leave, but von Braun's message to his friend Kurt Lindner is that, Kurt, I've made arrangements with our personnel department to give you a medical discharge. He says, you'll have the rest of your life, you'll get half your salary that you're making now, and you don't have the stress that you'll have if you stay here. So I've worked that out for you. You just got to sign these papers, and we'll work the deal. And Kurt Lindner says to him, Werner, he says, you saved my life in Germany. You saved my life bringing me to this country. He didn't have to, because Kurt Lindner also, before he got assigned to von Braun, was a member of the SS. It's the only way you got jobs, the only way you could manage in Germany at that time. So as a teenager, he joined the Boy Scouts, he called it. Okay, he was SS. But von Braun overlooked that and realized he was a good engineer. He made a contribution in the development of the V2, and he wasn't about to abandon him. So he gave him this offer of a retirement, half pay for the rest of your life. And Kurt turned it down. He said, no. He said, don't do that. He said, well, I'm going to sign the paperwork anyway. And he said, no, don't do that, Werner. He says, I'll go work for one of the contractors and come back and work on the program for you as a contractor.
Because their passion was there. Everyone was so passionate about the project.
That's right. And passionate about working for this kind of a man. I mean, he was so concerned about what would happen to the organization when these Germans were another 5 years older if he didn't have Americans to take over the key slots. And I heard him say that many a time. He was very concerned about that. And so that's how I got into it initially.
Okay.
And then I worked the F1 engine program for 7.5 years with my project office. We never were more than about 25 people in the project office. But I had interesting personnel that I dealt with. Well, at that time, we weren't smart enough to realize that what the immensity of the problem really was. So we felt like, well, we just had to work harder, and we'll get it done. And we had an excellent contractor in Rocketdyne for the development of the F1 engine, as well as the J2. They also were the contractor for that. And there was never a case of, I don't think I can do it. I think I can do it. I got a team of people that are right on top of everything, and I've got an excellent team at the contractor who also was on top of things. And so we just felt like we had to do it. We'd find a way. And on the F1 engine, we had a massive problem called combustion instability. And in fact, that still is around and people talk about it. Difficult to explain. Most people don't know what combustion instability is. But I use an example that you can relate to, and that is if you're sitting in a dark room, all the lights are out, doors are closed, and you light a candle, what are the mechanics that make that candle, instead of being the perfect shape of a Christmas light bulb, it flickers back and forth? Okay. Well, what's happening is that one side, it's a form of combustion instability. One side of the flame happened to see a little more oxygen than the other side, so it burned a little hotter. Pressure built up and kicked it over. Now this side, seeing fresh oxygen, it gets hotter than this side, kicks it back over, and it goes back and forth. That's a form of combustion instability. Well, we had that in the F1 engine. It didn't manifest itself that way, but we have a shower head design where oxygen is being mixed with fuel and being burned, and through all of these little holes in the injector. And what happens is that instead of it flicking back and forth like that candle does, a few times in a second, it flicks around and back and forth 2,000 times a second. 2,000 times a second. All right? And in so doing, it's overheating because it's seeing so much extra oxygen. It's burning more efficiently, and it's tearing hardware apart, and pretty soon the engine blows up.
So how do you overcome that?
Well, we put together a team from all over the country of who we felt were some of the best engineers or people who knew something about combustion. And we put that team together, and I gave them a $40 million budget. Go solve the problem, okay?
So you're saying a good budget is the way to overcome it?
Oh, yes. It took a good budget because ideas had to be implemented in a piece of hardware and tested to see whether the idea was right. And that was very costly. But I gave them this budget, and we drew from all around the country. We drew a professor from Princeton University who was known for combustion work. I remember his name because it was Italian, Professor Luigi Crocco. Okay? But he knew combustion. And then we borrowed a combustion expert from the competing company to Rocketdyne, who competed for the F1 and lost. Rocketdyne got the contract. Aerojet did not. But Aerojet had a wonderful guy who knew something about combustion. So we put him on the team, and Aerojet allowed it, and so did Rocketdyne. And then we had some excellent people from Rocketdyne itself. And we picked on a couple of people within Marshall Space Flight Center in those days. In fact, I turned over the management of that whole team to one of our top engineers in the laboratory here. He's now deceased, but his name was Jerry Thompson. And he was given that budget to go come up with some designs, find out what's going on, let's build some hardware, test it. And so that's how that program was continuing. And it spent a lot of money, but we came up with a design of baffles. This team looked back at the V2 days. They said, how come the V2 engine didn't have combustion instability? And it bombarded London during the war. So they came back to that design, and they found out that, well, that was a spherical head of a design, which was a lot different than our design, which was a flat plate shower head, where all the oxygen came in through a shower head device.
Okay.
And they said, well, how come they didn't have that problem there? And they went back and looked at the design, and they realized that not only did they have this hemisphere, excuse me, but they had small little rocket engines that went into it rather than a shower head. So they had all these smaller engines coming in from the side and the top. And they said, well, you think that had something to do with it? And I said, well, theoretically, that would be different. It wouldn't tend to amplify the the vibrations maybe as much. Well, we couldn't redesign the F1 engine injector at that time. It wouldn't fit in this vehicle properly because all the weights and all of the dimensions were kind of reallocated or pre-allocated. So we went ahead and decided to cut some hardware based on, can we come up with a compartmentalization on the injector by building some baffles in so that any of this circulation would be stopped by a baffle. And so we came up with several designs and tested them out, and indeed we found a design that involved up to 13 compartments now of this shower head. So we had all of these walls so that recirculation going around and around and across would be stopped by a barrier, and it was solid copper. But solid copper would melt with the temperatures we have in a rocket engine, so now we had to have holes through that and cool it with fuel. So if you look at the baffles, we actually have little holes punched in it with a hollow core, so there's fuel in there coming through the holes, so it cools the baffle. And at the same time, the baffle then maintains its rigidity, and it tends to attenuate the oscillations of the real flame down here.
So it was a dual purpose almost, because it was actually supplying fuel.
Yes. Yeah, we cooled it with the fuel. That was a technique we used.
Very interesting.
Internal to the baffle. And in fact, in the museum here, we have a copy. We have a baffle. I donated to the museum, and they have it down here, and you can see it very clearly. In fact, you can still see the heat was so intense that it bulged a little bit. It wasn't a perfect flat surface in there. It's got a little bulge in it.
Interesting.
But that wasn't good enough, because we just never knew how susceptible it still might be. And any perturbation in the flows of the oxidizer or the fuel might set it off again. So by that time we had been working on other programs with deliberately causing excitation of that type. So we developed a little bomb, small bomb, got screwed into the center of the injector. And as soon as we ignited the engine, we ignited the bomb. And the bomb went off, and sure enough, it started to initiate an instability, but the baffles immediately stopped it. So we did many, many tests that way, and it never went unstable again. So we felt like now we had the answer. And so when I had to, before every flight with man, we always had a manned flight review called. And all the project managers had to get up in those reviews and identify the problems they've had, how they solved them, what kind of confidence we had in the solution. Well, it was my turn. And here I come up there, and it was close to lunchtime, and I was trying to get through it as fast as I could. But nevertheless, one of the astronauts who was present asked the question, well, you've run all these tests with the bombs. How confident are you that it will work the next time? You know? And I didn't have any numbers to tell him other than how many tests we ran. But I said, well, I can tell you this, that of all these tests that we ran, we never had another case of spontaneous instability. But if you ask me, go run an engine this afternoon out here at Marshall and swear to you that I know it will not go unstable, I can't say that. But I'm pretty confident that it will not go unstable. And I'm rather, I said, okay. Well, as we were walking out the door to go to lunch, the astronaut grabbed me, put his arm around my shoulder, and he said, Sonny, we know you guys have worked as hard as you know how on this thing, and I know that you're sweating it. He says, don't sweat it. Go home and have a good night's sleep. We're ready to fly. Don't worry about it. So
they had the confidence.
That's right. They had the confidence in our attitude toward how we approached it and all of the testing we did, you know, and how we were open to interactions from other areas that might know something about it. You know, we didn't hold it to ourselves and not tell anyone we didn't have a problem. We didn't hide the fact there was a problem. We needed help. Wonderful. Wonderful. In fact, at that point, our confidence was just so high that I would never have hesitated to say okay for the next flight. And in fact, I wasn't the project manager at that point again, because during one of the early test flights, the J2 engine, which also has a cluster of 5 in the second stage, not our engine, but it's J2. The J2 is liquid hydrogen and liquid oxygen. So when it burns, it produces hot steam, basically. We burn kerosene in this thing, and when it fires up, it produces a smoke cloud behind it that's horrible to look at. Okay, very pollutant. Well, what we found out on the J2 in one of the flights was that the 5 engines fired okay, but the people who were monitoring the temperatures in Houston of all the engines to see what was going on detected that we must have had a little fire on board one of the engines. Well, he was concerned enough that he gave a cutoff to the engine. So instead of 5, we would have 4. Unfortunately, and this isn't known very well, it wasn't advertised, but the command that he gave, by the time it got to the engine, it got to the wrong engine. It was miswired in the instrument unit. So the computer actually cut the wrong engine. So it cut a good engine.
So then there was 3 engines left that were working.
You got it. And some of the gutsy guys in Houston made the decision, even though we never tested it, to run 3 engines that long. And so they let the engines fire until they used up all of the hydrogen in the tanks. And now the third stage, okay, which called the S4B, that stage had one of these same engines that we had in the S2 stage, where there were 5. But we had this one engine up there. Its function was to circularize the orbit around the Earth of the package we were sending to the moon. Okay? And after you circularize it, now you know the exact position with the computers we had, when to fire that engine a second time to translate it to the moon. TLI.
And did it work that?
No. It did not fire the second time. So I got the word that I needed to move over to pick up the fixes for the J2 engine, find out what happened, and fix it.
Okay.
And that took me 2.5 years to get to the bottom of that problem and solve it. And it was really a very simple fix. And so it just took 2.5 years to take care of that issue. And I have to give one of the engineers really good credit at Rocketdyne. They went back to look at the early firings of that engine just to observe what it looked like. And in the camera work and in the photography, they noticed one of the lines which carries liquid hydrogen to a little gas generator that provides power to the big turbine wheel, which then powers the main propellants into the combustion. Well, that little line carries liquid hydrogen to this little smaller combustor on the engine. It's like a little rocket engine on top of the big rocket engine, okay? And as he's watching the movies of it, he notices that something's dripping from this line. Now, the line is a braided hose. I'm not sure if you know what that means.
Right, it's real thick, and
it's thick, and it looks like it's been woven with a bunch of metallic wires, okay?
Okay.
It's called a braided hose because it looks like it's been braided, okay?
Is it kind of similar to what's underneath your sink sometimes?
Yeah, some of them use braided hoses
yeah,
yeah, or in the cars.
Yeah.
A lot of braided hoses are in the cars. But that's what the design was at the time. And this engineer looking at that says, how come that thing is dripping? In fact, I see ice on it. And then they began to realize that in space, they wouldn't have air to liquefy. This was liquid hydrogen so cold, it was liquefying the air around the hose. And so now it was dripping liquid air. And in places, it had ice that are, liquid water. It was now ice. And they said, in space we don't have that condition. I wonder if the vibration characteristics in space of that line are just radically different than what we see on Earth. It's being restrained by ice and liquid on the outside on Earth. So they said, why don't we make it a solid line and anchor it better and try working that. And they were able to take care of it. And that's what the final fix was. They just went to a solid line and anchored it better. And we never had the vibration problem in flight. It had been now, I don't know how many years. Well, it was 10 years. It was 7.5 on the F1, 2.5 on the J2. And now I decided I've got to take a vacation with my family. And I get a phone call from Von Braun's office saying, we just got a new project, and it's known as the Lunar Roving Vehicle. It's a car we're going to give the astronauts to drive, and we need a certified and a well-intentioned and want to make sure well-experienced, and you got the most experience at Marshall right now in project management work. Von Braun would like for you to consider taking the management of this new project. And I said, whoa, wait a minute. I said, I've spent 10 years or more in propulsion. I know something about propulsion now. Didn't then, but I know it now. I said, I don't know anything about a car, and especially one that's going to, I said I can drive one, but I'm sure I'm not going to know anything about a car that drives on the moon. So I was kind of being pleasant with him, but I was trying to tell him, find somebody else, please. I told him, 10.5 years, no vacation. And he says, okay, I'll tell Von Braun. The next morning he calls me again. Von Braun says, if you can manage a $1 billion program of the F1 and you can manage the fixes on the J2, he says, you're our most experienced project manager. You sure ought to be able to manage this simple job. It'll only be 17.5 months that you have to deal with it. He says, and if you don't have it by then, we'll fly without it. Okay?
No pressure.
No pressure.
No pressure.
$40 million project, 17.5 months, and we'll fly without it if you can't finish your job. So I said, aye, sir. So I inherited that as my last job. So now I do take credit for providing the astronauts, and I'm the only docent who can say this, I provided them with the transportation system and the rocketry to get them to the moon. When they got there, I had a car for them, and they didn't have to go through a rental agency to get it.
That's fantastic.
Well, we had apparently long before I was given the job of managing the program, there had been a lot of studies that had been made and a lot of alternate ways of getting transportation to the astronauts to move around the moon. But they found out on Apollo 11, as I recall, that the energy that was being expended by the astronauts just walking on the moon was considerably higher than they had anticipated. And they said, well, how are we going to really explore the moon if these guys, they can only walk the length of this building and they have to come back in because it's too much. Probably the biggest design problem we had was the wheels, because I had an amount of weight that I could not exceed, because this entire vehicle you see above us was already designed basically, and the weight had been already allocated to the different programs, and they were either on weight or overweight or close to it. And so I didn't have much of a capability to design a car that weighed as much as your car that you drive, for instance. In fact, the car could not weigh more than 480 pounds on Earth. Okay? Now on the moon, obviously 1/6 that. But on Earth, it couldn't weigh more than 480 pounds.
That's a very light car.
It's very light. had to carry the two astronauts, each of whom weighed as much as the car, fully packed with their water and their oxygen and their radio equipment. And it was battery driven, and so you had to carry these huge batteries. Each one weighed 56 pounds. Even though they were available technology, they weighed a lot. And so the biggest challenge was weight on that vehicle. So now we come up with the problem of, okay, what should a tire look like? What are we going to use as a tire? And the calculations we ran was, well, if you used rubber, if you even could use rubber, it ended up that each tire would weigh about 110 pounds. Just because you had to reinforce the rubber for the travel to the moon, because it was in a vacuum. And so now your tire, which you're used to driving, which has 14.5 psi around it on your car, this car had zero pressure in there, and on the outside, and whatever we fill the tires with would cause them to expand tremendously on the flight. So it was problems like that said you can't go with rubber. It weighs too much. I mean, if you have a 110-pound weight on one tire alone, you have 4 tires, that's 440 pounds. The whole car couldn't weigh more than 480, or this big vehicle couldn't get it to the moon. That was the problem we were faced with. Well, I like to tell this story because it just seems to be timely nowadays. But it seemed like a couple of the engineers working at the time on the project took a vacation. They were working in Santa Barbara for the Boeing company and for the General Motors company, which had teamed up on the LRV. And they hadn't had a vacation in a while. Unlike my situation, it was just a matter of months, okay? But they went down to Mexico with their families, went to Mexico City. And as they were walking around the bazaars and whatever, the street vendors, they noticed these young girls weaving, and they were weaving basket weaving. And they were doing it all by hand. And a light bulb came on and says, hey, if we could do something like that with wire, something like that, we might be able to have a lightweight car. So they brought the idea back to management. And they said, well, let's give it a try. So they set up a way of weaving the thing. And the problem was a magnificent solution to it, because where each tire, if I could have made it out of rubber and it could sustain the heat on the moon, which, by the way, could be as hot as plus 250 degrees. Imagine a rubber tire trying to operate in that environment. We could come up with a design using wire, and when we came up with it, and they weighed it weighed only 17 pounds. And
That solved your weight problem.
Yeah. So that made the whole vehicle possible. It made the mission possible. Otherwise, we wouldn't have gone to the moon with a car. It wouldn't have worked. I mean, it had to do fantastic things, like the wheels had to go into potholes that were 1 foot deep and 2 feet in diameter, and not tip them over. One of the people that worked with me on the project, who's also a docent here, Skeet Vaughn, he did a lot of the analysis work, of the photography work on the moon from satellites and what have you. And his job was to count how many holes and how deep they were, how big they were, how many rocks, how big they were. So he had a little bit of a feeling for what the vehicle was going to encounter. But nevertheless, it had to go into a hole that was 1 foot deep and go over a rock that was 1 foot high. Try to do that with your car. It wouldn't do too well. The testing that was done with men on it, the astronauts on it, they had a rig, I think it was at Houston, where they offloaded 5/6 of the weight with a crane and a cable system. So they picked up 5/6 of the weight with the astronauts sitting on it. And then they drove it over a course with this crane holding 5/6 of the weight. So they could get a little bit of a feeling for how the dynamics might work when they hit a rock or a hole. We were concerned from the beginning that the contractor could not do the job for that price. Government estimate was $40 million. I says his contract, he came in with a bid of 18 something million. And here you got two major contractors in the country, General Motors and Boeing, who had teamed up. And are we going to tell the world that we can't give them the contract because it didn't look like they could meet their costs? So when I gave my presentation at NASA headquarters, I was a little reluctant to recommend them over another contractor who was a little higher but had some experience. They actually built a vehicle that they ran out in the desert for some information. So I was a little hesitant on that. And we had a couple of classy guys in the office, my team, said, everyone was incentivizing contracts at that time. The whole industry was doing that, but we hadn't yet. We said, why don't we write the contract in such a way that if the contract overran 100%, the contractor would get zero fee. Okay? If the contractor didn't deliver the car on schedule, then this thing would fly without a car on the last 3 missions. He'd get zero fee. I don't care if he spent the $40 million, gets zero fee. He really got a big hit if he didn't do the job that he was proposing to do, and which we felt he couldn't do for that money or time. But NASA headquarters said, well, do you think they can do the job ultimately? I said, well, these are big industry guys. They know what they're doing. Yeah, I think they'll eventually do it. I just don't have the confidence in the cost. It was very evident that we were going into an overrun. We knew ahead of time we had a problem because the government estimate was $40 million for the job. And we knew we were going to be an overrun because he had done less than a third of the work and had spent more than half the money. So we decided we better start letting that be known and putting a team together to help them. Well, somehow or other, the word of a potential overrun got all the way up to Washington, and Congress heard about it, and they turned on the GAO to investigate the program. And I got the word from the chief engineer up in NASA headquarters on the LRV program, a fellow by the name of Ben Milwitsky. Ben calls me up and said, the GAO is going to be in contact with you. You're going to come down to Marshall and investigate the program. But in the meantime, would you prepare something for Rocco Petrone to give to Congress as to how we got into this mess? Very negative kind of attitude so far. So I get a call from Rocco Petrone, who is now head of the Apollo program in Washington. But when I gave Rocco Petrone my presentation, he was a very unhappy man. And I figured, well, I've been a project manager long enough. They'll probably demote me somewhere, because that's always the solution. If you can't fix the problem, get rid of the manager. So I was prepared to get a new assignment. But anyhow, I gave him an honest picture. I told him that, well, one of the things we did when we first tried to put this contract together with the contractor was not go through a simple cost plus fixed fee. So every time you made a change, you not only paid for the cost, the government did, but you paid a fee to the contractor. So what's the motivation for him not to spend extra money, okay? But here we now are faced with this cost problem now. Well, we prepared the story for Rocco Petrone to use. Well, he took that presentation and gave it to the congressional staffers. And I never heard a word from GAO. And July turned into August. And so I called my friend Ben Milwitsky and I said, Ben, haven't heard from the GAO. What's going on? He says, oh, didn't Rocco call you? I said, no. I figured he maybe thought he fired me already. But, you mean he didn't call you? I said, no. He says, oh. I said, why? What happened? He says, well, when he gave your presentation to the congressional staffers, they were so impressed with how you managed to protect the government's interest that they called the GAO off. Never been done, as far as we know. Even today. I don't know of any program that the GAO quit on just because the ground rules were so different in their mind.
Interesting.
So
Maybe
we didn't have the jail, so I still had the job to do. Doggone it.
It all worked out.
It all worked out, that's right. Oh, it's just awesome. And they fully enjoyed it too, you could tell, because they did a few things that they weren't supposed to do with it.
It didn't pop any wheelies or anything, did it?
They tried. But they had a contest, I think, as to who could drive it the fastest. Okay. It was great. They gave me the honor of driving on it. So I was pictured driving downtown Huntsville.
That's fantastic. Yeah, I was at the Dancing in the Streets
Yeah,
parade. And
yeah,
everything.
exactly,
It was
yeah.
really neat.
Yeah, we led the parade.
Whenever you were doing the testing for the rover, did you get to drive it then? I mean, the real
Oh,
ones
no.
back in, no.
No,
Yeah.
you can't.
So was that the
Can't
first
drive
time?
it on Earth.
Okay, so
Can't
that
drive.
was the first time you actually got to drive one.
That's right.
That's fantastic.
And it had rubber tires.
Right, exactly. That's true.
Don't give up hope.
That's a good one. That's a good
Yeah,
one.
don't give up hope. I mean, during the darkest hours that I was faced with, if I had given up hope, I would have turned my job over to someone else. But I hung in there, and now and then got a compliment from the astronaut when I gave him a presentation one day. But just hang in there. Do the best you can, and remember you have good people around you to help you do it. And give them the help that they need to make that work. That's what Von Braun did with me. I had no business becoming the project manager of a $1 billion program with the limited knowledge that I had at the time.
And
But
you
I-
saw
I-
that potential.
But I saw how he was as a manager of people, and I figured, well, he's got the formula. Maybe I can kind of mimic that situation. So I was always people-oriented in my office. And I had a few problems, personnel problems that were hard to deal with. But always hung in there with the people, always considered their needs. You've got to have a dream. If you don't have a dream, how are you going to make a dream come true? Those are the words from South Pacific, and they're just so true. Got to have a dream.